Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, I am Sufianti, majoring in Physics Education of Sultan Ageng Tirtayasa University. This video meant to fulfill my course assignment School Physics Learning Training. This video we will learn about radioactivity. So watch this video till the end and happy watching! Assalamualaikum warahmatullahi wabarakatuh. Good morning, student. How have you been? Good, alhamdulillah. Okay, I believe that you have been reading with your equipment, your handphone, your laptop, and your network can support our learning process today. And then, I will check your presence in WhatsApp group. So, please take attendance list by sending your pictures. Understand? Okay. Today, we will learn about radioactivity. So, let's start learning today. Okay, students. Before we are starting to study, I want to ask you something first. Do anyone know how a farmer gets their quality seeds? Anyone knows the answer? If you know the answer, please write the answer on the comment box below. Understand? One of the way to form a quality seeds by using radiations. Seeds are given radiations with varying doses, customized by needed. For example, rice plants. Radioisotopes used to trigger mutations in plants. From this mutations process, it is how can be obtained plants with favorable type. Yep, that is one of benefit of radiations in life. So, there are many more benefits of radiations in other fields. Radioactivity is ability of an unstable atomic nucleus to emit radiations and turn into a stable atomic nucleus. Okay, for the next, radioactive nuclei. Radioactive nuclei is nuclei that emit radioactive ray, including alpha ray, beta ray, and gamma ray. By the emissions of this ray, the radioactive nuclei is getting smaller and smaller. The rate of change of radioactive nuclei begins activity of the nuclei. A single radioactive isotope would have absolutely no way of knowing when it will decay, because decay process is completely random. However, if we have a large enough sample of radioactive isotope, then though we couldn't tell when any individual isotope will decay, we can still find out two very useful things. One, the activity of a sample. For the next, decay on radioactive ray, or we can say radioactive decay. Radioactive decay is a spontaneous emissions of radioactive ray. Radioactive decay consists of alpha decay, beta decay, and gamma decay. When we are talking about atoms, it is the number of protons and neutrons in the nucleus that determines whether the atom is stable or not. So, when they do radioactive decay, they want to change that number of protons and neutrons. So, let's look at what happened in alpha decay. Alpha decay is one type of radioactive decay. Alpha decay is an atom with a nucleus that is just too big. That's what
it is unhappy about speeds of 2 neutrons and 2 protons. These 2 neutrons and 2 protons here, they become together. So, we have this unhappy atom here that wants to slim down speeds of 2 protons and 2 neutrons that are flying out space. And we call that an alpha particles. So, let's take a look at how we write chemical equations that involve alpha decay. Let's start here with uranium. You will see that I use this type of notations that we call isotope notations. U is chemical symbol. You can see there are 2 numbers here. The lower number here is the atomic number, and it is telling me in this atom of uranium how many protons they are. Okay, now on this top number, please don't make common mistakes. This top number is not the number of neutrons, but this top number, the number represents the mass number, which is the number of protons plus neutrons. So that's what's going on. Uranium is going to undergo alpha decay in order to find out what's going to happen. Let's keep track of the protons and neutrons as they change the course of this decay. Neutrons and protons. For protons, it's easy to find out how many are in there because I just used this number here. The atomic number, 92. What about the number of neutrons? Well, the mass number isn't the number of neutrons, but it's the number of neutrons plus protons. So we can extract this number from this number, and we got the number of neutrons. When 233 means 92, I end up with 141 neutrons. After we have undergone alpha decay, this atom is going to sort out 2 protons and 2 neutrons. Protons from 92 down to 90. And for neutrons, we have 139 neutrons. Now, write a symbol of what we get. The first thing to do is find out what element on period table, the different atomic number of a new atom that we get. So, we are going to find out thorium. And don't forget to write the alpha particle either way, the neutrons and protons. An alpha particle you already know. The deal is here, it is 2 neutrons and 2 protons. Atoms do radioactive decay because there is something about their lives. There is something about themselves that they don't like, they are unhappy, or we could call that unstable. Then, so for an atom that wants to do beta decay, they have too many neutrons in their nucleus. On beta decay, a neutron turns into a proton and make an electron, and we could call that beta particles. So we want to know what happens when carbon-14 here undergoes beta decay. And then, here, there are 2 numbers to decide. There is a lower number here that represents the atomic number, which is number of proton. And the number up here is a mass number, which is number of proton and neutrons. The number of protons is 6. For number of neutrons, we can get by mass number means protons, so we get 8. Now, let's look at what I'm going to get after beta decay happens. It is that a neutron turns into a proton. So that means that after this happened, I started with 8 neutrons Now I'm going to end up with 7 neutrons. But I get a new proton because that is what the neutrons turn into. So I used to have 6 protons, now we have 7 protons. First of all, we need to realize that my carbon turned into a new element. So what you need to do is look on the periodic table and find out which element has 7 protons. It is turned out that it is nitrogen here. For proton, I use 7 and for mass number are protons plus neutrons. We find 14. And now, I don't want to forget about the electron, beta particle. There are 2 ways. One of them is like this. This is a Greek letter beta. Can you write 0 there and then -1? Sometimes people write like this with the A. Just like electrons of atoms, the nucleus of atoms can also transitions between energy states. When a nucleus of an atom moves from an excited state to a ground state, it can release electromagnetic radiations of very high frequency. Even higher than X-ray, such radiations is known as gamma radiations or gamma ray. In contrast to electron transitions, which generally release proton of low energy, nuclei tend to release proton of very high energy. We can write by chemical equations here. And then, the other important to know is half-life. Half-life, which has the definitions, can be defined either as the time taken for the number of radioactive nuclei in a sample to half. Mathematically, can be write with N equals N0 multiplied by 1/2 cube T/T1/2, with the N is residual total of radioactive, N0 is initial amount of radioactive, T durations of activity, and T1/2 is half-life. Okay, for the example, case 1. After 60 days, the radioactive substance that has not been disintegrated is still 1/6 part of the original amount. Determine the half-life of the radioactive substance. From these questions, we know that time of activity is 60 days. Residual total of radioactive equals 1/8 multiplied by initial amount of radioactive, and the question is how much the half-life. From these questions, we can use these equations with N equals N0 multiplied by 1/2 cube T/half-life, with the N is 1/8 N0 equal N0 multiplied by 1/2 cube 60/T. This is N0, N0 is the same thing, so we can move here, and 1/8 we can write 1/2 cube 3 equal 1/2 cube 60/T. And this is the same things that we can move here, and the result is 3 equals 60/T, with the T is the half-life. So the half-life here we got 20 days. Okay, this is for the other example. A radioactive sample contains each microgram of pure isotope having a decay constant of. Determine a half-life and mass of sample after 20 minutes. from these questions, we know that S0 and lambda determine a half-life and mass of sample after 20 minutes. The first thing to do, we can search the half-life, and this is we use these equations, and we got 10. So the other, we search mass of sample after 20 minutes with the half-life equations, with the n equals n0 multiplied by 1/2 cube t/half-life. With the n0 is h, the half-life is 10, and the time of activity is 20. So we got 2 microgram. Okay, for the next, we will discuss about radioactive sources. Radioactive sources are elements that can emit radiations because of their unstable nature. Some radioactive sources are natural and some are artificial. Okay, natural radioactive source consists of sky object, crust, and from inside of body. And artificial radioactive cores consists of a medical field and nuclear reactor. And then we will discuss about radioactive detections. On these pictures, you can see this is one example about radioactive detections. This is Geiger-Müller counter, or you can call GM counter. GM counter is a kind of a nuclear detector which is capable of detecting different kind of nuclear radiations like alpha particle, beta particle, and gamma particle. Here you can see the structure of such a device. Noble gas is located as a metal cylinder in the middle of the metal. And the other stuff to detections of radiations are film emulsions and scintillations counter. Okay, then I will explain about benefit of radioactive substances. The first, for medical sector. Benefits of radioactive substances in the medical sector are as follows. P.32 to detect eye, liver, and tumor abnormalities. And A24 to detect circulatory disorders. Fe59 to measure the rate of formations of red blood cells. The second one, for agriculture. Isotopes P37 and C14 to determine the right place of fertilizations. Isotope O18 to determine the process of photosynthesis. The third, for food technology. Gamma-ray radiations from the CO60 isotope is used to preserve foodstuff. And the other one, for industry. Radiations techniques are used for coating wood in many countries. The wood surface becomes harder, heat-resistant, scorch-resistant, resistant to certain chemicals, and has a more attractive appearance. Okay, this is radiation's impact. Radiation's rays have an impact to other. For example, this is the impact for organism. We can see this is the table of doses radiations with the impact. There are so many different doses with the different impact. The second one, for environment. Radiation pollutions in water will cause reduced oxygen and food for aquatic biota. And the other impact for economy, climate, and social and political. Okay, for the last, this is radiation's protections. For the first, radiation's time. Reducing the exposure time can decrease the affected dose proportionally. The second one is distance. The farther the distance from the radiation source, the less effective the dose will be. And the last is radiation shield. Radiation shielding is used to reduce the radiation dose to make it harmless to humans. Radiation shields are usually made of a thick layer of lead.
Thank you for watching, and I hope this video can be useful for us. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.